So over here, we're done with encrypting a plain text using the Cipher algorithm. And that's gonna convert a sentence like the quick brown fox jumps over the lazy dog into this um, what seems to be random characters, such that um, you know you can now send this message out. If anyone is snooping around in your communications, they see this message, they are gonna be like, well, what does it say? I don't know. It's encrypted, right? So the contents of your message is going to be safe, even if someone is snooping around and is able to look at all the messages that you're sending out. So this is encrypting. Um, what we want to do next is that for the intended recipient, once they get that weird message, they want to be able to decrypt it. So let's explore how we can change our program so that you can encrypt and then decrypt messages, right? Um, so what I'm going to do then is I'm going to actually um, turn this into a function um, so that we can reuse it, right? Because we are going to be using the same algorithm for encrypting and decrypting, right? So I'm going to turn it into a function. So function definition, the def keyword, I'm going to call it Caesar. And what happens is that this function is going to take in your text. I'm not calling it plain text or ciphertext, I'm just calling it text, and it's going to take in a key. And what's the body of the function? So everything here has to be indented inwards so that they become the body of this function. And they still also have to maintain the they still have to maintain the relative indentation also within there. And so, right, so you have your text, plain text. In this case, actually, I'm actually not gonna assume that the text string that's coming in is all in lowercase. So I'm gonna perform a transformation. I'm gonna call the lowercase function on it. And so any uppercase characters is gonna be transformed to the lowercase equivalent. Okay, so text. So I can't call it ciphertext. I'm gonna call this input text, right? Let's call it input text. Okay, and then the output of it is going to be called output text. And I'll have to shift this guy over into the function, right? Because the context of this variable is only within the function. It shouldn't exist outside of this function, right? And so instead of printing it out, I'm gonna return it to the calling function, to the calling statement. I'm gonna return the output text to it. Okay, so let's test it out. We've defined our function. Let's call Caesar with our plain text and our key, right? We're gonna get a sentence, a string back. So I'm just gonna go ahead and print it out. And I'm doing this to test to make sure that our transformation of our code into a function is correct. It works, right? So let's run the module on it, and it's not. Okay. Specifically, there's no lowercase function or string object, right? It's better that I know now, and I can fix this bug rather than writing my whole complete, really complex program, and then the error happens, and I will have a harder time trying to debug it, right? It's much easier to debug a smaller program than a larger program. And also, what I know is that I introduced the bug recently, right, in the last few changes that I've made to it. So now I just have to focus my attention in debugging to just those recent changes that I've made. Right? In this case, the recent change I made was to introduce the lowercase function. It has no attribute lowercase. I think I'm supposed to do it this way, right? I can go look up the documentation, but I'm gonna be a bit lazy and just think. I think I remember how to do it. I think the lowercase function is on the string module. Okay, so let's try it out. And if it doesn't work, I'm just gonna go and look up the documentation. Yep, it doesn't work, right? So let's go look up the documentation and figure out it's not in this common string operations. This is a string constant format pass. Let's see. So there is a capitalize, but where is that? Aha, click on it. String standard type, string methods, right? So let's take a look. Capitalize, case full, center, count, and quote. Ends with expand tabs, find, format, index is alpha. Oh, actually, there's this other function that we could have used. Is alpha. Rather than do this foresee in input, we could have done if if it's an alphabetic character, then it will return true. But never mind, it's okay. It's lower, it's numeric, it's printable, it's space. Oh, okay. So it's not just it's not lowercase, it's just dot lower, right? So I got the name of the function wrong. All right, so let's try running this again just to confirm that we fixed our bug. No, it's not. It's okay. So no, sorry, wrong. It's gonna be plain text dot lower, right? Okay. Let's run this. So it didn't work. And now it does, right? Now we don't get an error message. And it was important for me to test out my change before I move on, right? To make sure that my fix worked, because it may not work the first time around. Okay, so we have this turning our algorithm, Cipher algorithm, into a function works. And so now we can then make our plain text not be to be dynamic, not be defined the program itself, but we're gonna ask the user to actually input our plain text, input the plain text, right? So we're gonna say, oh no, it's not plain text dot lower. It's gonna be input text dot lower. Sorry about that. It starts to get a little bit messy, right? Okay. So over there, input, enter your string, enter your text, and then enter the secret key. Okay, and what we want to do for this one is make sure it's converted into an integer. So I'm gonna wrap it in the integer function, so then it's not a string but rather an integer. Okay, so let's run this. We made just a few changes but we want to run it to make sure that it works before we move on. Right, so we get the prompt, enter your text, the quick brown fox, the secret key, let's say 6, and I accidentally pressed something here, so I'm gonna run it again just so it's okay. I accidentally pressed the backspace vector, the quick brown fox, secret key is 6. Yeah, there you go, the quick brown fox, right? If you can decode it in real time. Okay. So this is for encrypting, and so then I'm gonna have another one, which is I'm gonna ask the user to tell me whether I'm encrypting or decrypting it. So I will ask the user, and I'm gonna store it in a variable. I need to think of a name for the variable. I'm gonna call it encrypt. and I'm gonna ask the user, are you encrypting or decrypting? And I guess I'm gonna ask them to either enter 1 for encrypt, 0 for decrypt. Okay, so then if is encrypt is equal to 1, right, then I guess is encrypt is 2, right? Otherwise, is encrypt is false, right? So we know whether we are encrypting or decrypting. Actually, we don't really need to know that, right? Because what happens is that if the difference between encrypting and decrypting is that if we are encrypting, we don't have to do anything. But if we are decrypting, we need to perform a transformation on the key. The key will be 26 minus of the key, right? To make us go in the opposite direction. Okay, right, so let's try it out now. Run module, enter your text. I'm gonna say the quick brown fox, enter the secret key 6. Are you encrypting or decrypting? Enter 1 for encrypt. Let's say we are encrypting and we get that. Okay, I'm gonna copy the ciphertext. Let's run the module again. Enter your text. I'm gonna enter our ciphertext. Enter the secret key. Are you encrypting or decrypting? We are decrypting. Let's see whether it works. Voila! You can see that our secret message has now been decrypted back into the quick brown fox, our plain text, right? And that's because of these 2 lines here. If we are decrypting, right, what happens is that the key will be shifted by 26 minus of the encryption key. That will be what the decryption key would be. Alternatively, we could have just made the key the negative of our key, right? So if I'm shifting forward by 2, when I decrypt, I need to shift backwards by 2, right? But instead of shifting backwards by 2, what I'm doing is I'm saying shift forward by 24. And that's the same thing as shifting backwards by 2, because it's kind of like our math is circular, right? Once you get beyond 26, you actually go back to 0. So that's the decryption, how we do a decryption.